Thank you. Good morning, everybody. Very happy to be here with you today, and especially after this very interesting presentation from a colleague from NASA. And today I will bring you on a completely different dimension of space. It's not the inspirational dimension that makes us dream, but it's a brand new revolution that we are living in these days, and it's the new space race. I mean, you were mentioning Kennedy before. The space race as of today is not any longer just the race for domination of space. The strategic dimension of space is certainly still well existing, but it's now coupled with something that is more linked to economy. So just wanted to give you some figures just to tell space by the numbers today. What does it mean, the economic dimension of that? See, we have roughly 2,000 satellites active today, and we have about 60 countries having a space program today that represents more than 20 countries more than 10 years ago. So we are really on a growing steep side of that. And this means that there is something attracting that goes probably a little bit beyond just the strategic dimension. And this different thing you see on the other side of the slide, that is what is projected to happen in the next 10 years or so. So where these figures are telling you that the economy in space is simply exploding. So we are actually pushing the frontier of space economy from the geostationary orbit 36,000 kilometers above the ground, pushing it to the frontier of the solar system as of today. We are settling in space, we are there to stay, we are there to make business out there. And this is the rise of the new space economy. It's an economy that actually is a revolution that is coming from the convergence of space industry and the digital economy. So this revolution is clearly happening and taking place mostly in the Silicon Valley, but now it is irradiating and the fallout are almost everywhere. I mean, in Estonia as well as in France, in Italy, in Germany, we can feel and live this every day. So this means that this is bringing a new philosophy, a new way of doing space. I mean, we are moving from 5 to 10 years to develop one satellite to manufacture and launch 4 satellites per day. So you can imagine that this is quite shocking, and you can be even more shocked if you think that this happened just in 8 years. So our engineers, our factories are simply not equipped to that. So it's now experiencing a tremendous change, and this is also exposing the whole sector to huge challenges. So we are, I must say honestly, a bit unprepared, even from really a mindset to adopt this kind of innovation. Because I mean, just to burst a myth, but space is considered often to be the most innovative field in engineering. Actually, our missions are extremely conservative, because you don't want to blow up your mission after 20 years of flight in space just because you have introduced an innovative technology that you have never tested before. So this means that sometimes what is flying over our head is 20 years old in terms of technology. 10 years to develop, 10 years to fly, and it has been tested and flight proven even before. So this means that we are a fairly conservative domain when it comes to big mission. And now, on the contrary, we have been exposed to this new mindset of the digital world that is bringing us to the idea of maybe we can test the thing in flight and we can afford to fail. And maybe failing is not a bad word at all. This is telling you something also about the mindset of Europe in terms of risk-taking philosophy, that we are definitely more risk-adverse. And this new economy, this new way of doing space is bringing thousands of satellites in mega constellation in space in the next years to come that will even increase the data deluge that we are experiencing in these days. So we will be simply submerged by data. Only today, just to give you an example, 5 satellites of the Earth observation constellation Copernicus in Europe, only those satellites are delivering more than 5 petabytes of data per day. So you can imagine that no human can analyze those data, and so we need to develop artificial intelligence and things like that. But this brings, and this is associated to new threats, of course. So if on one side there are certainly a lot of opportunities, there are also a lot of challenges that are still not really captured. Challenges related to the fact that when you're developing economy, of course, you're attracting also evil forces there. And when you are developing an economy also, sometimes your space is more crowded. And these have some severe consequences. The first consequence is that, if I manage to go further, yes, here it is that there are a lot of ways to attack our satellite to disrupt our economy that is booming now in space, because satellites are extremely fragile. So let's say we can go from electronic interference to laser interference to warming up the satellite, to heating the infrastructure, to blinding the sensors, to even physically damage through a collision, but also to spy, to spoof, to jam the signals. So I will also try to lead you in these slides, in these few slides, through what are the threats to which our satellites are exposed today. So, for instance, we can have ground-based lasers that can dazzle, that can really blind our sensors. This has already happened. But we can also have jamming in our infrastructures, and I will show you some example later on. But we can also have some physical attacks, so kinetic attacks on our satellite. And you know, these satellites are made of very, let's say, very thin aluminum structures, so they are extremely fragile, and they are flying at speeds that are in the order of 6 to 7 kilometers per second. So also these small fragments that are debris that are flying in space can severely damage our satellites. This is just an example. This is courtesy of NASA, and this is a small fragment, 1 millimeter in diameter, flying at 6 kilometers per second, that has made this kind of damage. And with the busting of space economy, these things are increasing. I mean, this is a distribution of objects with dimension across of about 1 meter. So we are talking about big chunks that are visible also from easily detectable from ground, thanks to, depending on the elevation, typically with optical telescope or radars. But when you go to smaller sites, 10 centimeters, as you can understand, the situation is getting worse. And here we have something like 400,000 objects of this dimension only in the low Earth orbits. So this means in the area between 100 and 2,000 kilometers from Earth. But when it comes to 1 centimeters, situation is even worse. And you see that also in the area that is the geostationary belt, so at 36,000 kilometers above the Earth, this is starting to be a very serious problem. And the minus or the dimension between 1 centimeters and 1 millimeter is in the order of 150 million objects. So it's something that you cannot track, and each of them has the potential to make the damage that you have seen before in terms of structural impact. So this is a severe problem that we have also to take into account, because the space economy is based on the exploitation of a natural resource that is called the orbit. Is called space. So we have to preserve this natural resource in order to support a sustainable exploitation of it. That's why we have started on one side to monitor the behavior of the population of these objects in order to avoid collisions. And this is today what is the only thing that is happening. But in the next future, we are also starting to imagine way to clean the orbit, to remove at least the bigger of these objects. So this is, I couldn't help showing a robotic aspect of this, at least when coming to Robotex. This is the minimum I could do. So this is one of the satellites that is currently under study for a mission with a robotic arm to deorbit a big satellite. But this is not the only technology that is currently under development. We also have some fancy concept like a net to capture other satellites. But just to tell you that this is a serious problem, and the kinetic impact could be used either in a malicious way or in an unintentional collision, but both the results will be, let's say, will have severe consequence on the functioning of our satellites. But the one thing I wanted to discuss with you today a little bit, is since we are in Estonia. Estonia for us is considered to be the place to be when it comes to cybersecurity, is the cybersecurity aspect of these threats. And it's clear that we are taking these things very seriously. And I would say that half of this presentation that I'm showing you today could not have been discussed in public just a few years ago. I mean, most of the things that I will show you in terms of examples here were classified events just a few years ago and could be discussed only in different circles, like that in a public conference. However, these are very interesting examples, and I have made just a selection of some of them. Not most have been published anyway, because, of course, it denounces also the fragility of some business, and so it undermines the credibility of the business itself. So you understand easily that operators that have been exposed to this kind of threats are not very much inclined in disclosing information. But this has been publicly done, so now we can discuss about, for instance, this first example of the German-American satellites, which has been attacked, the control taken, and the satellite rotated. So it's actually an attack on the telecom and the telemetry chain, and the sensor has been blinded by rotating it directly to the sun. Other two examples are interesting, the second and third bullet, because in that case, the operators never realized actually to be under attack. So for more than 6 months, their satellites were potentially under the control of a third party, but they never realized that this had taken place. So they realized it only in post-processing months after that. But examples are many more. I mean, some are very recent. I mean, when it takes a denial of service or jamming of GPS signal, the very latest event took place just a few kilometers away from here a few weeks ago in Norway during the maneuvering of Russian army. All the GPS was denied in the northern part of Norway. So this now have been clearly attributed, but was very difficult to attribute this kind of event in terms of forensics, so to know who was perpetrating the attack a few years ago. Now we start to cooperate and to exchange information about that, so it's a little bit easier. You understand that this new space, this digital revolution that I was telling you before, is also bringing a new challenge in terms of cybersecurity, because when you have to buy 4 satellites per day, of course, this is changing also your supply chain. As an effect of globalization, we are buying our components for our satellites worldwide. We can buy components from China, from the US, from Eastern countries. So it's clear that if you want to keep the production pace and rate high and the cost low, it's clear that a number of security check or control check have to be reduced, and this exposes the satellites to the risk of embarking malicious components or infected components or malware that can manifest only when the satellites now is flying. And this is also something that is happening, and I can tell you that in some cases this attack, depending of course on the capacities and resources available to the attackers, are already happening and are really of very high quality. Just to give an example that has been very recently declassified, is that a random generator code from some of our highly sophisticated military satellites. Random generator code is actually the one code, the part of the machine that is needed to generate the security access code to the satellite. It was based on a chip. The chip has been controlled, and the topography of the chip was exactly as foreseen on the blueprint. So no difference, and all the same, the random generator code was not random at all. So after less than half an hour, we were able to break in the code. So there was something wrong, and it took us something like 6 months to understand that there's been doping at atomic level of the material in which the chip has been etched. So you understand that this is not a kind of attack that is available at the resources of any hacker. And here this means that it is obviously a superpower that has developed this kind of capabilities, but they exist. So we have now to take this into account. And how do we react? We have been developing now in Europe the first ESA cybersecurity range for space. This is in the Belgium Ardennes, so in some hills at the frontier, at the border between France and Belgium. It's a center that is providing training courses for our operators, so the scenario for the red and blue teams are updated every 3 months, but actually there is a full and complete chain of telecommand where you can test your capability to attack and defend a satellite. This is very important for our people to learn how to react. Now, this is of course also open for to use to commercial entities and companies and governments in Europe, but we have plans. We have plans for improving these capabilities in the next month, and actually Space 19 Plus is the big event for the European Space Agency Administrative Council. Will take place at the end, in 1 year from now, actually, so at the very end of 2019, where ministers will gather around the table to put some 10 to 15 billion euros for next space projects, and a substantial part of it will be devoted to increase this capability in terms of not just having the training for the operators, but also to have a capacity to test and evaluate and assess the new architectures of our spacecraft in order to be more robust in terms of cybersecurity, and also to develop an operational capability to monitor in real time the security of our spacecraft. So I would say that yesterday evening I was in a cybersecurity meetup hosted as a side event of Robotex, and we have been presenting and discussing more in details, let's say, some of these cybersecurity aspects. And I've concluded with a challenge that we can imagine in the next month to come. I mean, the European Space Agency has developed a test satellite that is able to be, let's say, exposed to cyber attack. We are developing really this to test our capability, and we would like to launch a kind of grand challenge to the cybersecurity community, and this could be interesting. So that's why we have called this Hack My Sat, this kind of attack, because we would like to test and to challenge the community to defend and react more, to make more robust our space infrastructure in order to be capable in the future to support more and more the economic dimension of our space activities. And with that, I would like to leave you the floor in case you have some questions for me. Thanks.
Lovely. Thank you, sir.